everyone. So till now we have the basic idea about what is STP, how we can enable the STP, what are the issue we are going to get if we don't have STP. And we learn how we have the king switch, that is a root bridge. We know in our network we will have one switch as a root bridge or king switch. And how it is selecting, we already learned. We will have the priority plus MAC address. If all switch is having the same priority, then he is going to look the MAC address. And how all switch is getting the information with the BPDU, because every 2 seconds all the switches are exchanging the BPDU. In the BPDU we will have the information about the MAC address, priority, port cost, all that information is present in that one. So we told switch is going to update the database and they are going to select one switch as a root bridge. All other switch will be non-root bridge. And then we told we have the port priority. If I open GNS3, I think I have somewhere that topology. Let me check if I have. Maybe because we will use the same topology if we have that one. Let me take, maybe it is having the same. Okay. So if you see here in the switch, we saw the cos also here. When we type here show spanning tree, if we see here what we have, this is a port, that is the interface, and this is the role of the port, and let me make this big, and this is a state, listening, learning and forwarding. We are going to discuss what is this state. And then we have the cos, and then we have the priority, and this is a port number. This one we discussed still here, but anyhow let me repeat again. What we are saying, whenever we put show spanning tree, we will get the table, that is VLAN 1. If we have only VLAN 1, we will get the detail for only one VLAN. If you have VLAN 2, VLAN 3, more than one VLAN, we will have detail for all VLAN. What detail we are going to get? We are going to get the bridge, that is a king information. This is a king information we are going to get. After that we are going to get the bridge, means this switch information, priority, MAC address, and then this switch port detail we are going to get. So if we see, this switch is having 3 interface involving in the transferring of the data. If we see, this is a switch 2, this switch is having 3 interface. And if you see in that one, what we have, designated, designated, designated. Designated means it is forwarding the traffic, and this is in the state, and this is the cos of that one. Why we have cos 19, we are going to see that one also. And this is a priority. Priority by default all ports is having 128, and dot 1, this one is the port number. If you see fast Ethernet 0/1 means dot 1, and this is a port 2, that is here port 2, this is port 3, because of the port number, just port number is representing here, and this is a point to point, means directly connected. So this one we discussed already. Now what I am explaining here, port priority, this is a by default we have 128 all the port. And if you see this one I wrote here. If you see here, let me show you this one we are discussing this point here in this scenario. G0/0, I have the another switch where I wrote this one. That means that is the interface, and this 128 means the priority, and dot 20 means the port number, and P2P means how it is connected. Whenever we have the P2P means point to point, that is a full duplex. And whenever we have the SHR means shared one, means when we have the half duplex, it will show us SHR. If you see here what we are getting here, P2P means full duplex. If we have SHR means it is a half duplex, like a hub. So this one till here we know, we have the idea, we discuss this one, and also we learn this in the CCNA level. In CCNA we discuss this in detail. So now what we are saying, port, we will have different role of the port. If you see this port, that is the interface, we will have the different role. We have designated port, root port, alternate port. And if you remember before what we told, who is king switch here? I think this is a king. Let me check this is a king or not. Let me check. Sundar, you can switch off your camera. If you see here, okay Sundar, you can switch off your camera. It is showing here. Okay, so if you see here, what I am saying here, we are saying that we have the root bridge. One switch will be root. So imagine this is a root bridge or king. We will check which one is a root. So we will discuss the port also. So I will go inside the switch, and here if I check this is a root bridge or not. Here nothing is written here. See here we have anything here. Nothing is written here. This is a root bridge. No. Yeah, this is a root bridge. Okay, this is a root bridge. So I will say let's look for the VLAN 1. So VLAN 1, this is a root bridge for the VLAN 1. This switch 2 is a root bridge. We are looking for the VLAN 1 now to understand the concept. So whatever port we have to this switch, that will be the DP, designated port. Okay, whatever port we have in the root bridge, that will be designated port. We will say that is a DP. Okay, we will say DP, and opposite to DP we will have the root port. If you see here, opposite to this king switch, this is a king switch. Opposite to king switch we will have the root port. So this one is a root port, and the other port maybe we have the block 1, that is alternate port, or maybe designated port. So this is a designated, this is a alternate port, that is a block. So now we are saying wherever we have the king switch, that all ports will be DP, designated port, and it is always forwarding the traffic. Opposite to this one we will have the root port, and that is directly connected to the king switch. And other than that one we will have some are designated, some are alternate port. Alternate port will be the block port. Whenever we have any issue in this link or any other link, this port is going to become as a designated. Designated port means he is going to forward the traffic. So now we will see in our theory, this one I wrote here already. So if you see spanning tree port role, we have designated port, we have non-designated port, root port, alternate port, forward port, and the block 1. Block means it is not forwarding the traffic. So if you see here in the designated port, here a non-root port, because designated port should not be root port. Root port will not be designated port. Means here if I show you, we are saying whatever the port we have opposite to king switch, that will be the root port. So root port will never be as a designated port. Designated port is separate, the root port is separate, but both are going to send the traffic, both are forwarding the traffic. What difference we will have? Root port will be directly connected to the king switch, and the cost will be the shortest. Example, if anyone want to go from here to here, cost we will have short cost compared to the other route. Example, if I want to go from here to here, how much it will cost me? If I want to go from here to here, how much it will cost me? If we compare from the root port to the king, it will have the less cost. Imagine, I will say here 19 as a cost. How I am writing, I will show you. Here also 19, here also 19. Why I am writing 19? Because when we are using the fast Ethernet, cost will be 19, and if we are using Ethernet, we will have the cost will be 100. And when we are going for the different, as the speed is increasing, cost is decreasing. If you see, we need to remember this box. Here what we are saying when we have the speed of the link is 10 Gbps, then the cost will be 2. If we have the 1 Gbps, cost will be 4. If you have the 100 Mbps, then cost will be 90. If you have cost 10 Mbps, then cost will be 100. So we are using the fast Ethernet. So fast Ethernet speed will be 10 Mbps. So cost is 19 here. But if we are using the Ethernet, then cost will be 100. And if we are using 1 GB, then will be 4. And if you are using 10 or above, then we will have the cost 2. So this box we need to remember, and we can say with this one we have the cost. And if we see inside the switch also, we will have the cost. If you see, we are getting here as a cost 19. Because we are using the fast Ethernet. If you see, this is a fast Ethernet, speed of the link. fast Ethernet is having the cost 19. So what I am saying here, this cost is 19. So all the interface, this one we are using fast Ethernet, here also fast Ethernet, here fast Ethernet, all interface is having the cost as 19. So this is 19, here also 19, here also 19. If one guy want to go from here, example, if this guy want to go to King switch, because we have the rule, whatever traffic we are having in our network, that traffic need to go through King switch only. Okay, that traffic need to go through King switch. If this PC is sending the traffic, this PC, this is a PC, imagine PC3 want to send the traffic to PC2, we have the rule, all the traffic need to pass through King switch. So this traffic will come from here to here, it will charge 19. It will charge 19. Imagine if this traffic is coming in this direction, again going like this, it will charge more. Or imagine if any other traffic is coming from here to here, it will charge 19, again here to here it will charge 19. So total cost will be 19 plus 19. Okay, so what we will do, wherever we are getting high cost, that link will be disabled. So this will be automatically blocked. So our traffic will go from here this way, here to here, only it will cost 19. So they will select the low cost path, wherever we are getting the high cost path, it will block that link. Example, if we are sending any traffic from here to here, this traffic need to go to King switch. If this traffic is going from this way, it will cost 19 plus 19, that is a 19 plus 19. Okay, if I go from here, if I am sending, if I go from here directly, it is 19. So this is charging less cost. So this path is preferred, that's why this is blocked here. So now just remember, we have the cost 19 here, 19 here, 19 here. Okay, so what we are saying, lowest cost, where we will have lowest cost in the root port. If you have the root port, if you want to go from root port to the King switch, the cost, whatever it charge, it is the lowest cost. If you see, here is 19, here is 19, that's why it is charging low cost, because it will connect directly to the King switch. So just remember, root port will be opposite to the King switch, role of the root port. So here we are saying designated port. So we are saying designated port is a non-root port which is forwarding away from the root port, means it is forwarding the traffic from the root switch. And maybe we will have more designated port. It is not necessary only King will have the designated port, maybe we will have here also. If we go inside this switch, this is not King switch, here also we will have the root port. If we see here, show spanning tree, we will have here also designated port. So what designated port will do, they will forward the traffic. So this is status, if you see, they are forwarding the traffic. So designated port, root port, both are different. Root port will be opposite to the King switch, designated port will be available in the King switch, and also other place also. Rule of the designated port is they are going to forward the traffic. And we have non-designated port, that is having the high cost. So just now if you see, if we check here, this one is a non-designated port, because of that one this port is blocked. If we go here and if we type here, show spanning tree, this is a non-designated port, we have the alternate port and it is blocked. Alternate means we are keeping this ready whenever we have any issue in the topology. Example, if any other link go down, this link will go up, and that time it will start from the block to forward. This FW means forwarding, BLK means block. So this will be the block port. So what we can say, we have the root port also. Root port means it is always in the forwarding and it is directly connected to the King switch. Alternate port is in the alternate way, it is standing as a alternate. Whenever we have issue, it will start forwarding depending upon the BPDO, depending upon the election. If you want, I will show you. Imagine I have this link, I will switch off this interface, fast Ethernet 0/1. I will go here in this switch, I will write here interface fast Ethernet 0/1. I will write here shut. If you see, I switch off this interface fast Ethernet 0/1. So after that, if you see, this link will go up. This is a alternate. Okay, this is a alternate. Let me show you. I put this as a down. Now if I write here show spanning tree, we have one port as a block, but now if you see this fast Ethernet 0/2, but now fast Ethernet 0/2 is saying that root port, and it is in the listening. It is in the listening. For which VLAN? This is for the VLAN 1. So what is listening, learning, forwarding, we are going to discuss. So what I want to show you, we are saying this is a alternate port, but whenever we have any issue, example we have issue here some issue, this link go down, so automatically this port is going to start working. That is nothing but alternate, means he is waiting for the issue. If we have anything go wrong, it is going to take care and he is going to start automatically. So let me enable this link what I put down now. Interface fast Ethernet 0/1. I will say no shut here. So this go up now, and after that forwarding means it is having the designated port or the root port. Forwarding, where we have the port as a forwarding. If you see, this one is the forwarding. Forwarding we will have maybe our root port may forward, or maybe designated port may forward the traffic. If you see here what I am saying, I have here, I am saying example, if this guy is a king, this port will be DP. DP means forwarding the traffic, and this port will be root port, and this port also root port. This also forwarding. So what we are saying, forwarding state where we will have maybe in this one or maybe in this one, both are there. So forwarding state come under DP or RP, not other than that one. Block port will not forward, alternate will not forward. So this is some terms we need to remember. And block means we can block also by saying that shut down the interface, and we can block that one, so it will not forward the traffic. And cause, just now we discussed, this is a cause, so we need to remember the cause also. Like different Ethernet connection is having different cause, so we need to remember this cause box. And this cause also we can have in the short form or long form. Let me show you if it will support in the packet tracer or not. Example, if you see here, I will write here show spanning tree. If you see here, we have the cause here 19 19 19. If I write here one command, spanning tree VLAN 1, let me check this command is available. No, I think this command is not available in the packet tracer. Anyhow, later we will see in the GNS3 or EVNG that path cause, because if I write here it is not working. I think this is not available here. Anyhow, cause is same, but it look in two form. One is short form, one is long form. Later we will see that one. But this is the main, each and every switch by default it is enabled in the short form, that is a 2 or 4, 19 and 100, this form only. Long form is it is written to in the place of instead of 2 it will write as a 2000. It will be big form. Some scenario maybe you will notice that one, but mostly brand new switch is having this standard form only for the cause. Then we will go for the STP ports status. As we are saying here, if you remember just now we are saying this port is listening, learning. What is that one? We will discuss that one now. If we see here, let me write here enable show spanning tree. So we are saying now, if you see, this is a status here, this one, this is a role, and this is a status, and this is a cause. So if you see status, this is forwarding. FWD means forwarding. So what are this status? We are going to discuss now. So if you see here, whenever we connect the link to the switch, example, if I have one switch here, I have another switch here. When I connect it with the cable, it will take 30 to 50 seconds to start working. 30 to 50 seconds it will take to start working. If you see in packet tracer, let me show you so easily you can understand. I will take two switches here. Okay, let me take 2 switches here or 3 switches, because it is already connected. So here I will connect. If you see, I will connect from here to here, here to here, and here to here. If you observe, it is taking 30 to 50 seconds. It is not working. This ambered color means not working. It is taking time. When it become green, that time only it will work. Before that one, it will not forward the traffic. So see how much time it is taking. It will take 30 to 50 seconds. Okay, it will take 30 to 50 seconds. 30 to 50 seconds it will take. Still it is not. If you observe, now it become green, now it become green. So what we are saying that one, it will take 30 to 50 seconds. So what is 30, what is 50? First we will go. Whenever you connected the two switch, switch will go first in the listening and it will take 15 seconds. Then it will go in the learning, it will take 15 seconds. So it is total 30 seconds. If switch is working and just we connected the cable, so it will take 30 seconds to start working. To forward the traffic, it will take 30 seconds. Let me repeat again what I am saying. Whenever you connect the cable between two switch, it will take 15 seconds for the listening, 15 seconds for the learning, and after that it will start forwarding the traffic. So we need to remember this STP port status, and then we have the listening and learning and blocking, forwarding, disable. So blocking means, example, if you put the port as a shut and then you will write no shut, so then he will take extra 20 seconds. He will take 20 seconds when we put shut and no shut, or this port is someone shut this one or block this port one and no one is using this one. Maybe you disable this port or you remove the cable, or in simple way you can put shut and then again you put no shut. So that situation, it will take 20 seconds to move from blocking to listening, and then again it will take 15 seconds to move from listening to learning. Again he will take 15 seconds. So what we are saying, 15 plus 15, and first it is coming from the blocking, so 30 plus 15 plus 15. That's why we are saying 20 plus 15 plus 15. So 20 plus 30. That's why we are saying it will take 30 to 50 seconds to start working. If it is not blocked, then it will take 30 seconds. If it is blocked, then it will take 50 seconds. So we need to remember now, we have the states. What states we have? In the STP we have the state, switch will listen, then he will learn, and then it will start forwarding the traffic. If it is in the block state, then from the block he will move to the listening, it will take 20 seconds, and from listening it will take 15 seconds, then from listening it will go to learning, it will take 15 seconds. After that it will move in the forwarding, and in the forwarding no limit, it will start forwarding. And if you disable the port, it will not transmit or anything, it will no limit, it will not start working. Okay, it will not start working. So now we have the idea that STP port is having the state. We have listening, we have learning, we have blocking, and we need to remember the time also. It will take 15 seconds, and if it is in blocking state, it will take 20 seconds. So if anyone asks you in the interview, what are the how much time it will take if you connect to switch, or when we connect the switch it will start transmitting data immediately, you need to tell it will take 30 to 50 seconds. Why 30? It will go for listening, it will go for learning. If it is coming from the block, then it will take 50 seconds. So now we have the 30 to 50 seconds. What he will do in the listening? In the listening he is going to take the BPDU, because whenever you have the switch, whenever you connect the switch, it will go the BPDU. Okay, this switch will send the BPDU, they are exchanging the BPDU. So this guy is listening that one and he is learning that one. Algorithm is calculating and they are saying this guy is a king, this guy is not a king. So they are doing the election in that one. That's why it is taking the time. So what we can say, after blocking state, root port designated port will move to the listening. During the listening state, port discard the frame received from the attached network segment. Means if PC1 want to send any traffic, they will not take. When they are in the listening state, they will discard. And during the listening state, ports, the frame, whatever frame our PCs are sending, they will discard. After listening, they will go in the learning, and in the learning also they will not take any frame, whatever frame our PCs are sending, they will discard. After listening they will go to the forwarding. In the forwarding they are going to start forwarding the frame, our PC frame, whatever our PCs are communicating. So in the listening learning they are listening the BPDU, they are learning the BPDU, and they are checking who is going to become as a root bridge, who is going to has a king port, king switch, they are doing that one. So in the blocking state, like if we have any interface is block, it will listen the BPDU, they will listen the BPDU, but he will not forward any frame. So he will take 20 seconds to move from this blocking state to listening state, and after that it will go to learning, after that it will go in the forwarding. And disable means it will not work, it will like a only off mode. We are not using like we unplug the cable, or maybe we did not connect the cable like that, or maybe cable is broken, that will be the disabled state. So this is a state, just we need to remember, because in interview they will ask you about the STP state, so you need to remember this one. It will take 15 seconds for listening, learning, and 20 seconds for blocking. These are the state. How we can check means you can go into any switch and you can type here. If you see, this is a state. Now all are forwarding, but if we go for the other switch, here in this one we will have the different state here. If we check here, let me write here, show spanning tree, enter. If you see, this is in the forwarding, this is in the block, and this is in the forwarding. But if you remove one port and put again that port, example I will remove this cable, okay, again I will put this cable here. So now if I go here, they will have listening, learning, like this we will observe here. If we go, we write here show spanning tree, show spanning tree. If you see, okay, they went in forwarding directly. This is block, so let me remove this and put this one. Maybe I will remove, I will connect again here. Now let's see this port, it is doing very fast. Okay, if you see listening, learning, then they will move. So now LSN we have, it will take 15 seconds, then you will have listening, learning. Let me check here. If you see, now it is learning. Okay, before what we have listening, now it is learning, and after that it will start forwarding. So this they are going to do this this way. Whenever they switch on or whenever we connect the cable, now it becomes as a forwarding, so it will start forwarding of the traffic. So nowadays we are saying why we need to wait 30 to 50 seconds. Why we need to wait 30 to 50 seconds? We are saying we don't want to wait that one. Okay, we are saying we don't want to wait that one. We need more fast, because when we start our PC, example Windows 10, it is booting very fast. No need to wait, just we need to start working. So for this situation we have the different thing, like we have RSTP. RSTP, rapid spanning tree. Rapid spanning tree means it will do very fast. This will do very fast, they will take less than 10 seconds. Before, for the normal STP, what we have, STP or per VLAN, PVST, STP, PVST same only. In the STP we are saying only one VLAN. If we have more than one VLAN, we are saying per VLAN spanning tree protocol. So both are taking how much time? 30 to 50 seconds. To overcome these steps of issue, we move for RSTP. Here we will take less than 10 seconds. So we have less than 10 seconds. So if we see here, I will show you that also. So before going to that one, let me show you. We have different types of STP. We have different types of STP. Just now we check STP. This is a standard one and it will work in any vendor. This is a open standard 801.D, 802.1D. This is a standard and it will consume low resources. Conversion time is little slow and it is running one instant, means one spanning tree will run one instant. If you have 100 spanning tree, we will have the if we have 100 VLAN, it will run 100 spanning tree. Okay, if we have 100 VLAN, it will run 100 spanning tree. So we have the per VLAN spanning tree. These both are same only, but here we are having the multiple VLAN. Here we are discussing only for one VLAN. So if you see PVST plus, PVST is same only. We have little advantage if we use the PVST plus. We are going to see that one also. This is a Cisco proprietary. It will consume the high resources means it will consume CPU RAM more compared to STP, and it is little slow, and one for each VLAN. Because we have per VLAN, so he will do the per VLAN calculation. And then we have the RSTP. Here we will have the rapid, they will do fast conversion. We are going to see that one. Then we have the rapid PVST. The plus means it is having the some advantage. It will support the .1Q protocol. I will show you. We will discuss that one. Then we have the MSTP. So till here we already learn in CCNA level this one. This one is not there in the CCNA. We are going to see more focus on this one. This is a new topic. It is not present in the CCNA. MST, multiple spanning tree protocol. Why we need this one? Why we need multiple spanning tree protocol? Because when we are running the spanning tree, it will taking our CPU and RAM. If you are having, imagine if you are having the 200 VLAN is running in your switch, it will do the calculation for 200 VLAN separately. So it will take lot of RAM and CPU of the switch. To overcome these types of issue, what we will do, we will create one instant. Imagine we created one group and we will put all the VLAN in that one. So it will calculate one time. Or if I give you another example, you have the Active Directory. If you have the server knowledge, we will have Active Directory. If you want to apply some policy or some permission or some any rule in the user, in organization, if you have 200 user, if you want to apply any rule to the user, you need to log in and you need to click one user and apply rule one by one. 200 times you need to do. But if you create one group and if you add all the user and apply the permission or any policy on that group, all the user will have that one, as we are doing in the Active Directory. Same thing here. What we will do, we will create one instant and we will add the VLAN. So all calculation whatever is happening here in one time only it will happen. So it will not consume the CPU and RAM. If we don't create the MSTP, each separate VLAN is having separate calculation, each guy is running separate calculation, and we will have the separate table. If you see here, maybe if we have here, I hope we have multiple VLAN here in this one. Let me check here how many VLAN we have. Show VLAN brief. We have 2 VLAN here. Okay, so if I run here show spanning tree VLAN, show spanning tree, you will have 2 table. If you see, we will have the table for this is a VLAN 1 table from here to here, and this is a VLAN 10 table. So we are having calculation separately for VLAN 1, VLAN 10. If imagine if you have VLAN 10, 20, 30 till 200, 300, you will have 300 table here, and it will calculate and it will run. So it will eat CPU and the RAM of the switch. To overcome that type of issue, we will go for MST. But in the enterprise network, we don't have lot of VLAN. So even if you did not run MST, multiple spanning tree, it will work. But if you are working in the service provider, they will give the multiple customer, they will have the different VLAN for different customers. So in that they will create the MST in that field. So let's see, before going to that one, let's see what are the difference between the PVST. PVST is nothing but per VLAN spanning tree. PVST is nothing but per VLAN spanning tree. But now we are discussing plus. PVST plus is nothing but it is proposed by Cisco. This is a proprietary Cisco protocol and it will work only in the Cisco device. And what are the difference between the PVST and PVST plus? PVST plus will support the .1Q trunking encapsulation. This encapsulation is supporting by the PVST plus, whereas PVST is not supporting. So no one is using now PVST, they are using only PVST plus only. Nowadays most of the guys using the RSTP only, rapid spanning tree. But to understand the concept, we should know we have the STP, the spanning tree protocol. This is a basic STP, and then we are saying PVST, that is PVST and PVST plus. Then we have RSTP, and then we can say R PVST, per VLAN spanning tree plus. So this way sequence is going. So generally in the organization, no need to do any configuration. By default it is enabled. If you want, you can enable the PVST RSTP, or if you want, we can do the MST. Other than that one, just we need to understand the concept. What is that? What is doing that one only. So what we told, PVST plus is nothing but it is supporting the .1 queue trunking, and it will take 30 to 50 seconds to move from the blocking state to forwarding state. Imagine we have the VLAN 1 here, VLAN 2, VLAN 3 like that, and we have the root port for VLAN 1 this guy, root port for VLAN 2 this guy. So here we have the multiple VLAN, that is known as PVST, per VLAN spanning tree. So separate VLAN is running separate spanning tree. And we have the rapid PVST. Rapid PVST is nothing but it will do calculation more fast. Here what we have, it will do the calculation less than 10 seconds. If any physical link fail, it will do less than 10 seconds. Before it is taking 30 to 50 seconds, but here we will have less than 10 seconds. How they are doing this one? Because if you remember, we have the state here. Just now we discussed listening, learning, forwarding, blocking, disable. If you remember, here we discussed. So in the listening, switch is going to listen. In the learning, they are going to learn, and then they will forward, as we discussed. Same thing we have in the rapid, but in the rapid what we have, we will not have the disable and blocking and learning. These three we don't have, discard. Directly he is going to learn. Listening we don't have. Directly is going to learn and forward the traffic. That's why it reduces the time. In the STP we need to go through all this state. That's why it is taking the long time. But in the RSTP what they done, they remove this disable, blocking, listening. Directly switch will jump into learning and then it will forward. Then it is going to do the forwarding. So how we can enable this one? How we can enable means just one command we need to type, spanning tree mode rapid PVST. So with this command it will enable in the switch. If you see show spanning tree, you are getting here RSTP. RSTP means it is enable RSTP. So all other calculation, everything will be same as we have here inside. Only this one will increase. This state will be removed from here in the RSTP. All other thing will be remain same as we have in the STP. So let's do that one. So you will have the idea what I will do here. I will take let me take two switch. I will take two switch to show you RSTP. One switch is here and we have one more switch here. I will connect the two cable. I will connect two cable, one here and one here. Okay, I connected the two cable. And if you want, I will remove the port label so you can easily observe that one, what issue we are getting. So let me remove this one. And if you see here, this is a port we have. Okay, if you see, it is taking the time 30 seconds. Okay, 15 seconds for listening, 15 seconds for learning. Let me make this copy. I will copy this one. I will paste this. Okay, I make one copy of this one, same thing. Control C, Control V. Select that one and press Control C, Control V. Now it become green. This one become as a green and one port is blocked. So by seeing this one, we can say this is a king switch. Okay, because this port are green, so this is a king switch. This port will be green, so we will say king switch port will be DP. Okay, and opposite to king will be RP, and this is a block. Why block? Because if anything go here, it will come same with this link back. So that's why this is a block. So now if you see here, in this scenario this is a king, in this scenario this is a king, and this one is a DP, designated port, always forwarding the traffic. This is a RP, root port, it is also forwarding the traffic and it is directly connected to the king switch. And this is a block port because it is creating the loop in the network. That's why it is blocked. We will see why only this is blocked, why not this one is blocked. We are going to see that one also, or if you want I will show you before going to the RSTP only. Let me enable the port here. I will go in the preference, let me enable port. Okay, or show, always show. Okay, anyhow I enable the port here. If you see, we will look for this one. This is a king switch, and this is a non-king, that is non-root bridge. So one will work, one will not work. If you see, this link is not working and this port is fast Ethernet 0/2. Okay, fast Ethernet 0/2, and if you see this also fast Ethernet 0/2. So we need to remember, whenever we connected two switch, I connected two switch like this. Okay, I connected two switch like this. This is a king switch and this is a non-king. So this port will be green both and one port will be blocked. Which port will be blocked means we need to check in the king switch the port in the king switch who is having the high port number. Example, this is a port 2 and this is a port 1. So this port 2 need to block, but he will not block king port. Opposite to king port he will block. That's why this port is blocked. Let me connect the other cable. Maybe you are saying this is also port F0/2, this is also port F0/2. So maybe you are thinking this is a king switch, all ports are green, this is a non-king, so whose port number is high, he will block. Yes, he will block, but he will not check this switch high port number, he will check the king switch high port number. Okay, so if you have doubt, what I will do, I will change the port here. Okay, what I can do here, I will move this port. This is a 1, right? So I will connect here, maybe I will connect to 022. Okay, I connected 022. Now I will make 022. Okay, if you see here, I will write here, maybe you cannot observe here. Let me write here. See here, the up one F0/2 and here also F0/2. So let me write here somewhere F0/2. Somewhere I will write here F0/2, so we can disable the port and we can check F0/2, this one, and here also we have F0/2. Okay, and if you see below is F0/1, here is F0/22. So below will be F0/1 and here will be F0/22. Now let me disable the port number, so you will observe that one. I will remove this one. Okay, so this up one, okay, this is a king switch. Okay, this is a king switch, so all ports will be working. This is a non-king switch, here one port need to block. So what I am saying, whatever port is having the high number, that is going to block. If you see this switch port is having, this one is having high number, that is this is a port 22, this is a port 22 and this is a port 2, but this one is blocked, port 2, not port 22. Why this one is blocked? Because we are going to see the king switch port, which is the highest one. So this is the highest, F0/2, and this is the F0/1. So this port need to block, but king switch port we cannot block. So that's why the port which is connected to him directly, that port is going to block. That's why this is blocked here. Okay, I hope it is clear now. If you go here, they will do the election. How they will do election? If I write here show spanning tree, see here, this is designated forward, cause, priority. This is the king switch. So let me take the non-king so you can understand easily. This one I will take, this is a non-king switch, and let me write here enable show spanning tree. If you see here, I am saying this port is blocked. How it is blocked? I am saying first they will check the cause, both are having same cause, so they cannot block. They will check the priority, they have the same priority, they cannot block. Then they will check the port number. So whoever is having the high port number, he is going to block that one. So this guy is having the high port number, but he will not block, he will not check in our switch, he will check in the king switch. So king switch is having high number to this one, that's why it is blocked. Clear or any issue? See here what I am saying, they will first check, they will go in this sequence, they will check here cause, they will check the priority, cause for this interface is same, they will check in the king switch, cause will be same for both interface, priority will be same for the both interface. So then they will check the port number, who is having the high port number, they are going to block that one, but they will not block the king switch, they will block the other guy port. let me check. Yeah, okay. So now we will enable the RSTP. Okay, so what I will do, I will go in the CLI of the switch here, and it is easy, just we need to type here. First we will enable, then we will write, go in the global configuration mode, then we will write spanning tree mode, which mode we want to enable. If you see, we have here rapid PVST, so I will say rapid PVST. I enable the rapid PVST here. Okay, in this switch I will copy this same configuration. Now I will go to the switch, this one, and I will go again in the global configuration mode. Which switch we are enabling? We are enabling the up one, right? This one we enable, yeah. So let me enable here only. So I will go here, I will enable here also, enable config T, and then I will put this also here. If you see, I will write show spanning tree. If you see here, we have the RSTP here. Okay, show spanning tree. Let's see what option we have. Summary. If I write here, you can say where I wrote show spanning tree summary. So you can see rapid PVST is enabled here. Rapid PVST is enabled here. Now we enable the RSTP here. Now we enable the RSTP here. If you see this one, this port is blocked. Okay, or here in this scenario we don't have RSTP. Okay, example, I will disconnect this cable. Okay, I will disconnect. See, I disconnect this cable. How much time it is taking? See, this one is still embed. How much time he is taking? How much time it will take? 30 seconds it will take. It will take 30 seconds. If we can't, let me remove again. I want, or let me delete. I will delete like this. Or let me, first thing what I will do fast forward. The uplink is working, this one. I will take this cable. Okay, I will take this one. I will cut the cable, and then we will observe here. It will take, if you count 1, 2, 3 like this, after 30 seconds it will start working. This is a normal. We did not enable the RSTP here. Here is PVST or STP, you can say. For concept purpose, STP is here. We did not enable the RSTP. Still it is not working, see. So our devices, whatever connected, they need to wait 30 seconds. They need to wait 30 seconds. Now it is working. And imagine if this link came back again. If this link came back again, it will take again 30 seconds. It will take again 30 seconds. Why they are taking 30 seconds? Listening, learning, then they will go for forwarding. So our PC, whoever is sending the frame, any traffic to any other PC or any other server, they need to wait 30 seconds. They need to wait. We need to overcome these types of problem. For that purpose we do RSTP. So if you see here, still it is taking time. Now what I will do, I will take this one. Okay, this cable, I will use this cutter. I will cut here. If you see, this link is working. Okay, I will cut. You need to observe here this point. I cut this one. See, immediately it is becoming green. Immediately it is working. It is not taking 10 seconds also. It is taking less than 10 seconds. Again I am connecting. See here, immediately it is start working. If I connect, observe again, this link is up. I will connect. See, this one go immediately in the forwarding. See, immediately it is going in the forwarding. So what we are saying, RSTP is used for in real scenario. In the real scenario, in all the companies, they are using RSTP only. Many companies, they will enable the RSTP only, rapid spanning tree protocol. So now we have this concept clear. We are saying RSTP is taking less than 10 seconds. And how we can check? Show spanning tree summary you wrote, you will get this output. I wrote here and I have this output. We can check this way. Okay, so this one we can say RSTP. And BPDU, we already discussed what we have. BPDU, all the switches are sending the BPDU. BPDU is nothing but it is a bridge protocol data unit. It is having the message which is going to exchange between the switches. And I think we already check also. If we go in the simulation mode and if we look here, maybe here or anywhere, if I play this one, they will start sending the BPDU. If you see here, this is a BPDO. It is going to this port, but this is having the PC, he is rejecting that one. So every 2 seconds they will send. If you see, he is sending here. Even this port is blocked, he is receiving the BPDO, because in interview they will ask you, if some port is blocked, it will receive the BPDO. Yes, it will receive, it will process the BPDO, but he will not forward the traffic. He will not forward the traffic. And in our previous class, what we checked, we have the 3 types of BPDO. One is configuration BPDO. First time we will use the configuration BPDO to select the root bridge. After that also configuration BPDO they are sending every 2 seconds. And if anything change in the topology, they are sending that topology change notification. Another guy is replying that one. We check in our previous class that one. Okay. So what we are saying, we will have the 3 types of BPDO. In interview they will ask you what is BPDO, what is the purpose of BPDO. You can say BPDO is nothing but bridge protocol data unit. It is sending every 2 seconds in the switches, and they are exchanging the information about the switch ID, that is a priority, switch port. They are sending to the multicast address, multicast MAC address. And we have 3 types of BPDO. Configuration BPDO. Configuration BPDO is nothing but this BPDO, this all information is present. And whenever there is any changes, they will send the topology change notification. In this one we don't have any information, just we have here what we will have only notification saying that something is changed in our topology. And the other guy, whoever receive, they will acknowledge that they receive. Again they will send the configuration BPDO. They will do again election, and they will select the root bridge depending upon that election. And if you see here, this is a packet I put here. Same thing what we are seeing here, STP. If you want, we can open any packet like this. Double click this one, you will have this packet. We can increase the packet size, and we can see what we have in the BPDO. As we are saying, BPDO is having the priority and all that one, so we can check also. If you see this one, if we go here, what we have, this is a spanning tree BPDO. Here we have the root ID, root bridge MAC address. Root ID means whatever the priority of that guy, root 1. And after that, if you see, we have the bridge, means the bridge 1, the guy switch itself is his information we have. Then we have the priority also. And if you see here, we have the maximum age time, forward delay. We are going to check what is forward delay, what is maximum age time. And we have the hello time. Every 2 seconds they are going to send. So all this information is sending in the BPDO. Every 2 seconds they will send. And if you remember, before we done DTP, dynamic trunking protocol, that also going on here. If you see, this is also going on here, DTP. Before we check already this one. So DTP is also working here. So CDP is also working. Still we actually we learn already CDP, Cisco Discovery Protocol. We already learn in the CCNA. So that is also sending here switch. Anyhow, later we will see CDP also, but we don't have CDP here. So what we can say, BPDO is having the hello timer also there here, and maximum age time. So what we can say is spanning tree timer, this one. So we will see what is the spanning tree timer, what is hello timer, what is forward delay, what is maximum age. So if you see what we have, hello timer. Hello timer is nothing but the time that is BPDO is sending. Default spanning tree hello timer is 2 seconds. Default it is 2 seconds. Every 2 seconds they are going to send the BPDO, configuration BPDO. We can change this one from 1 to 10. We can change this one. If you want to change, we can change. But in the real scenario, in the production network, we are not changing. But for lab purpose, if we want to change, we can change. And then we have the forward delay. Forward delay is nothing but the time which is taking to listen and learn. That is nothing but forward delay. We are calling forward delay is 15 seconds. That is nothing but listening and learning. The time taken for the listening, learning, that is known as forward delay. So it is 15 seconds. We are saying 15 seconds for listening, 15 seconds for forwarding. If we want to adjust, we can adjust from 4 to 30. But in the production network, we will not change. And we have maximum age time. That is nothing but that timer. It will wait till that time. If he did not receive, then he will remove that information from the database. So by default, the spanning tree maximum age time is 20 seconds. But if we want to tune, we can tune from this value to this value. Switch assume the topology change must occur if the BPDO age time is out. Means maximum age time, just remember this is a time. In that time they will wait. After that, if we did not get any BPDO, he will think there is something wrong in the topology or something changes, that's why we are not getting, and he will remove that information from his database. And how we can change this timer means this command. First, if we want to check, we can write this command as we are using from starting, show spanning tree VLAN1. And if we want to change, we will write show spanning, that is spanning tree VLAN1. If we want to change VLAN1, we will write VLAN1. If you want to change for VLAN2, we will take VLAN2. Whatever VLAN, then hello time and whatever time you want to give. Same thing for forward time, we can use this command to change. We will do this one, so you will have more idea. Let me take any switch we can go. Let me first of all put in the real scenario. Let's do here, or yeah, here we will do. So what I will do, first of all we will check here what is our time here. Forward delay, whatever forward delay we have, all that one we will check here. After that we are going to modify. So how we will check, we will write here show spanning tree and press enter. If you see show spanning tree and press enter, you have here like if we see here 15, forward delay is 15, maximum age time is 20, hello time is 2 seconds. And if you have confusion, let me show you, let me highlight that one, this one. This is a hello time is 2 seconds, and this is a maximum age is 20 seconds, forward delay is 15 seconds. This is for the king, this one is the king, and this is the root. Root is having this time 20 seconds, all are same. Now let's change. I will go in this one. I want to change, I will write spanning tree. Which VLAN I want to change? I have only VLAN 1, I will change for VLAN 1. But in the production network we are not changing anything, just for lab purpose I am showing you. VLAN 1, I press question mark. So what I can change, I want to give priority, or I need to change the root. So I don't want to change this one, I want to change the hello time. Okay, this command is not available in the packet tracer, so we will do this one in the GNS3. Okay, we have already here topology. Let me open any one switch and we will change in this one. Because some commands are not working, you can use EVNG also, no issue if you want to do in EVNG, because sometime we are facing issue in the GNS3. Many guys are saying GNS3 is a mother of trouble. Always we will have the trouble, but it is working fine for me, no issue. It will work for you also, but if you are having issue, better jump to the EVNG. Both are same, we can use any one. Okay, I think some guys are getting that issue before, maybe he did not join today. Anyhow, so if we face any issue in the GNS3, use the EVNG. And now we will do for this switch. So I will go in the global configuration mode, then we will write the spanning tree VLAN 1. Example I want to do for VLAN 1. Press the question mark if you want to check. Yeah, it is supporting. If you see, you have the forward time, hello time, maximum age, and the priority and the rule. So we are interested now to change the hello time. So I will write hello time, and what time I want to give. Hello time is 2 seconds, but I can change. If you don't want, you press question mark, you will get. It is a range from 1 to 10. In this switch, I can change from 1 to 10. By default, we have 2. Let me change as a 5. So I change as a 5 here. I change as a 5. Now I want to change the other time. So what I want to change? I want to change example forward time. So by default we have 20. If you want to check the range what is allowed, 4 to 30. So let me change as a 30. I will change 30. Now I want to change as a forward time. We finish, so maybe I will change the maximum age. Maximum age by default is 40. If you want to check the limit, we can change from 6 to 40. So I will put as a 5. 5 it will not accept. We need to give 6 to 40. So let me take as a 10. Okay, I change already. Now if you want, I will write show spanning tree. So if you check here what we are getting here, because only one switch is running, that's why this guy is saying I am only the king. Only one switch is running, that's why this guy is saying I am only the king. And here if you see what we change, hello timer we change as a 5 second, maximum age we change as a 10 second, and forward delay we change as a 30 here. Okay, forward delay is changed as a 30 here. By default what we have, if you remember, by default hello timer is 2 seconds and maximum age is 40 seconds, and if you see this one is a 20 seconds. But now we change. So this way we can change, but don't change in the production network. Don't change in the production network. So this is the basic till now whatever we learn in the CCNA level. Okay, so now we will go for the port fast. After that we are going to do the MST. Okay, then we are going to do one lab scenario, where we can look how we can before MST we will do that one, no issue. Okay, so let me stop this recording, else video become lengthy.